And Mark Tinker will continue with the peering jargon.
So there's a lot of terminologies used in the peering game. There's a lot that we might not look at, but we'll look at the most common ones. They might be related to peering or also non-peering functions, but also as part of the entire peering process. We'll look at them in alphabetical order as well. Right, so bilateral peering is basically relationships that tend to get set up directly between two networks. The opposite would be multilateral peering. We'll look at that later on. This could be typically over a public exchange point. Carrier-neutral data centers, facilities where customers tend to install their infrastructure. The data centers are not bound by which networks you're supposed to connect to and so forth. Hence, carrier-neutral. So you can pretty much connect to anybody in the data center. Cold potato routing, basically situations where networks tend to maintain the significant amount of the traffic on their network because it's either cheaper or it's because they can guarantee some form of quality of service. This opposes the hot potato routing, which we'll look at as well. Colo, which is short for co-location, is typically where data centers, customers would co-locate equipment at data centers for either for peering, for infrastructure, for transit, or for any other kind of business. Dark fiber, so these are fiber pairs that run between any 2 points. There are fiber pairs that could be either leased from a company that builds fiber. There could be fiber pairs that you've built yourself. The point is that they are not lit. They are dark, so you could pretty much run them with any kind of equipment at either end. Data centers, purpose-built facilities that basically provide power, cooling, space, and other kinds of network services. Demarcation, when you're doing turn-ups with peers, your demarc information would include stuff like your rack numbers, your patch, panel, and port numbers, any kind of cross-connect circuit IDs, and so forth. So if somebody says, what's your demarc information, they're basically asking for that type of information to run their cross-connects and so forth. Default free zone is basically situations where service providers tend to run a full BGP routing table without a default route, hence default free zone. So that's basically a full BGP table. Depeering, which is the opposite of peering, which is what we're talking about here, is when networks decide to stop peering with each other, either mutually or not mutually. Downstreams, typically your customers, is what you'd call your downstreams, or depending on your topology. Eyeballs would be your end users. If you're a broadband heavy network, you don't do a lot of content, but you do a lot of customers, like typically incumbents who have broadband. Their customers would tend to be called eyeballs, and this is important for content folks because they'll use this kind of terminology. A lot of eyeballs in Africa, a lot of eyeballs in Asia Pac, and so forth. So what they mean by that is end users, customers who are using, the websites, Google search, Hotmail, or whatever, any kind of content or resource. Facility could be synonymous with data center or colo, so those tend to go hand in hand. Full circuit is the opposite of half circuit. So in this case, you're looking at maybe pricing for an end-to-end circuit. Some providers will say we're giving you X price half circuit. So say maybe from Johannesburg to say Mozambique, they'll charge you half circuit all the way to the border in South Africa, and then the other half will be taken care of by somebody else. Full circuit would be end-to-end, so you don't need to worry about the other side. Depends on the capabilities that your providers can offer. Half circuit, like we've seen, is the exact opposite. So you don't really know what the entire cost will be until you get the quotation from both sides of the connection. So hot potato routing is where networks tend to want to offload traffic as quickly as possible, especially smaller networks that can't afford to transit that traffic for too long on their network because it tends to be costly. So closest exit is hot potato routing. Interconnect charges, so this would be monies paid by peering parties for them to interconnect. It could be cross-connect charges, it could be charges to get to a meeting point and so forth. These tend to be ironed out in the peering contract if there is one. International private lease circuit, so basically a lease line that would normally span 2 or more countries. Looking glass, a device that would permit anybody interested in learning about what kind of routes you have on your network. The route views is a very good example of a looking glass, as well as the routing information services and so forth. Lit fiber is the opposite of dark fiber. So fiber driven by DWDM, driven by SONET, driven by SDH, is fiber that is basically pre-provisioned by the network, so they can't sell you the fiber or lease you the fiber as an entire circuit. You just pay for bits of bandwidth that you need off the fiber. Mandatory peering is where members at an exchange point are forced to peer with one another for one reason or another. This would be different from the bilateral peering. Meet-me rooms basically tend to be centralized passive cable switching panels where cross-connects tend to be cross-connected. So the meet-me room would be a location where half a circuit goes in, half a circuit goes out, and that's the meet-me room. Multilateral peering, so peering with a group of networks through a single negotiated policy, which is the opposite of bilateral peering. The utilization of things like route servers, which one of the presenters will talk about later, is how you implement those kinds of peering policies. No peering policy, networks that generally implement this kind of policy are not interested in peering with any other kind of network. We look at some other policy or types of peering policies as well, open, selective, restrictive, and so forth. Off-net traffic, so traffic that's handed off to another network at some point in its flight. So traffic gets into your network from your customers, it's on your network. Once it gets off your network, it's off your network. On-net is the opposite, and basically traffic that remains on your network for as long as possible is on-net traffic. These terminologies tend to get important when you're considering things like expansion, costing, and size of the network. So open peering policy, general policy is where peers are okay to pretty much peer with anyone with no major restrictions. Paid peering, similar to transit peering, where one network pays another for access to its backbone, but then here the network is being paid provides connectivity only to its customers and not the entire internet. In some cases, the network also provides connectivity to its peers only, but not to its transits or upstreams. This is important if you do stuff like regional-based internet services or local routes or things like this. Peer is any network with whom you exchange traffic. Peering is the act of exchanging traffic with a peer. Peering coordinator, we've looked at that already in great detail. I think what we've said is try and establish a peering coordinator, or maybe have your network engineers double up as peering coordinators for the smaller networks, or if you can't afford a dedicated peering coordinator. Basically somebody that handles peering related matters and so on. Peering policy, set of guidelines by which network operators will peer with external networks. Some networks have peering policies, some don't. So it's always good to look out for this. Point of interconnect is basically a location where peering partners will meet with each other and perform peering. Private peering is the opposite of public peering. So peering that doesn't involve any kind of traffic hitting the public exchange point. This could be back-to-back connectivity between your equipment and your partners, or your peering partners' equipment. Public peering is mostly done over exchange points, normally for no fee, apart from maybe membership charges for joining the exchange point. Restrictive peering policies tend to be those where the peering partner is generally not interested in peering with any network, but might be open to it depending on what kind of attributes you can provide, such as size of network, size of capacity, ratio of traffic, and so forth. Route registries, centralized databases where AS path information, prefix information tends to be stored for automated filtering at some point in the life of a network. For those of you who might have been here early in the week, we looked at RPKI as some kind of evolution from the route registries. Route servers, you'll look at that in more detail in the next presentations, but basically a centralized router at a public peering exchange point where multiple peers can peer with the device and end up receiving everybody's routes automatically. Selective peering, again, this kind of policies where normally some networks are happy to peer provided that a minimum set of criteria are met. Settlement-free peering, so in this case, neither party pays the other party for exchange of traffic, and the opposite is settlement-based peering, where money does exchange hands, for instance, transit or partial transit. Traffic ratios tend to be the balance between how much traffic a network sends to its peers versus how much it receives. Some networks look at this information, some don't, some think it's archaic. But yeah, most networks will say if we have the same in and out amount of capacity, then we're more or less the same size, so we can peer for free. Transit is where a network pays another for access to the global internet, or in some cases partial internet, which would be partial transit. In this case, money exchanges hands. Transit free, this is the so-called tier 1 networks that don't buy transit from anybody, and most, if not all, of their connectivity is done through peering or through customers. Upstreams, basically networks to whom you hand off traffic for onward forwarding to the internet, and these would be your transit providers. And that is the end of that slide.